接下来呢，会由 Mano 给大家带来谷歌地球 API 的这个介绍。那么 Mano 首先会讲一下整个的一个基本的概况，然后讲一下一些基本的组件是如何的使用，比如说地标、线条以及 KML 文件等等相应的一些知识。这样呢，大家可以利用它来建造一个简单的谷歌地球 API 的一个应用，然后嵌入到你的站点。下面我们有请 Mano， 谢谢。
Hi. I'm really happy that you all came today, and I'm really honored to be here. This is my first time in Beijing, and I'm really excited. I haven't actually gotten to see much besides the hotel and the Google office, so I'm looking forward to it. And thank you all for staying till the end of the day. I know this is a really long day, and there's been lots of great content, so thank you all for staying very much. So the first thing I want to do is talk, what I'm going to do today is I'm going to talk about the Google Earth API. So the Google Earth API is a JavaScript API used to control the Google Earth browser plugin, which we released about a year ago, last May at Google I/O. So it's really just about a year old. And it allows you to embed a 3D version of Google Earth into a web page and then programmatically control it. So first I want to give just sort of a brief history. In 2004, in October of 2004, Google acquired a company called Keyhole. Keyhole produced a product that later became Google Earth, but also importantly to Google, it had a big storehouse of imagery, satellite imagery, from all over the world. And that was used both in Google Earth and in Google Maps. And you can see here in 2005, Google released Google Maps and then Google Earth, and then the Google Maps API. Now Keyhole, the product that became Google Earth, which was just called Keyhole, already had a programming language, an XML programming language called the Keyhole Markup Language, or KML. And so when Google released Google Earth, they just continued to develop KML. So then in 2005, we also released the Google Maps API, which allowed you to programmatically control the Google Map within the browser using JavaScript. This is actually done accidentally, by the way. Sorry, I digress into a little bit of history. It's done accidentally. We released Google Maps, and then people around the world, particularly Paul Rademacher, who wrote housingmaps.org, created, they reverse engineered the product, and they figured out how they could programmatically control Google Maps themselves. And we sort of had two choices. One, we could sue them. We could send our lawyers after them to make them stop. Or two, we could hire them. So we hired Paul. And he worked on many products, but later came to work on the Google Earth browser plugin. So in 2006, we released version 2 of the Google Maps API, and that's what most people are using today. Although you know from earlier presentations that we're just releasing the early versions of version 3. But it wasn't until May of 2008 that we released the browser plugin, which had a integration mode with Google Maps. So here we're starting to see finally the 3D version and the 2D version coming together. Then last November, in case you haven't been watching, we released the Google Maps version, and just last week at Google I/O, we released a better Google Maps and Earth integration, and I'm going to show you a little bit how that works. So today, I'm going to show you the very basic code that's needed to set up these applications and do some interesting things. And then I'm going to do a lot of demos to, I hope, inspire you into the kinds of things that people can do. Okay, so the First thing is a demo. What does this actually look like? So here I'm clicking on it. This is a Hello Earth. This is the basic Google Earth in a browser. And of course I'm having, the demo gods are smiling on me again. Let me just try reloading that. There we go. So you'll see a plugin loads, and then you get the 3D version of Google Earth sitting in your browser. And that's not just an image. You get full movement around. So you'll see here, I can move it around, and I can tilt and get a nice, can pan around, and a nice smooth three-dimensional experience, all in the browser. This was actually, I worked a lot in the KML developer community before the plugin came out, and it was one of the most commonly requested things was, can I get this, and can I get this in my application? So this is the basic code that makes up what you just saw. I stripped out the HTML, but here, let's just walk through a few bits of this. How many, just a quick question, how many of you are Google Maps developers or have developed with Google Maps API? Okay, so not many of you. For those of you who are, some of this will look familiar. You'll see at the top there's the first script tag that loads the Google common loader. So this is our common JavaScript API loader. It loads some common libraries. And then, having loaded that in, you do google.load earth1, which by the way is what's on my t-shirt. And this tells the Google common loader to load the libraries for the JavaScript browser plugin. Then here we create an object, GE. It's just commonly we call it GE, you can call it whatever you want. And then have an initialization function, google.earth.create instance, map3D. And that map3D, all that does is it looks for the div element, which has an ID of map3D. You could call that whatever you want. And then it has a callback, an init callback, that's an initialization callback, what happens when the initialization succeeds. It also has a failure callback. And I didn't put the failure callback in because I've actually never seen that happen. So this is the initialization callback. Just takes this null object here and creates an object out of it. It just assigns this object to it. So the initialization callback automatically gets you the object that is the browser plugin. And then here, you take the object, you get the window of it, and you set its visibility to true. And that's all. That's the basic building blocks. That's your hello world, your hello Earth, as we call it, of loading the browser plugin. So this is just a diagram that shows the interactions between the different components. So you have, on the far end there, you have the Google Earth plugin. So that's the plugin that works with your browser. And it has an API, and then your JavaScript code causes that, it interacts with the API, which then interacts with, sends commands to the browser plugin. And I'm said this in my last session, and I'll try this again. If you have any questions as I'm going along, feel free to interrupt me. And if you want to summarize or translate at any point, you're welcome to also.
Just one question.
Yes?
You never see the feeder callback used. What kind of language network is problematic? The network.
I'm sorry?
If the network condition is problematic, what happens? Is that
They can. I just don't tend to develop under that conditions.
Can I use it as a way to fall back maybe to a static map?
You can, although if your network has failed So the question was...
It may be a special China problem, you know, sometimes we cannot get direct connection to Google, but still we can use that to do the fallback?
Yeah, so that would be a good use for the failure callback, would be if you can't make this network connection or to connect to a particular piece. Yeah, that would be a good use for it. We also provide within the API the ability to check whether or not they're using a compatible browser, and also whether or not the plugin is already installed. So if they don't have the plugin, you can check with that in the initialization callback. You can actually check that before you initialize, so that you don't even bother to try and initialize if they don't have the plugin installed, if that's your choice. Or you could display some message that says something if you choose. Any other questions? Okay. So here's some of the capabilities of the browser plugin and the Earth API. One, obviously, you can load Google Earth into your browser It's a pretty tremendous advantage. You can programmatically control the viewpoint. So one of the nice things is you can integrate, just jumping to the last point, integrate with other JavaScript APIs, including our Maps API, or just your own Java code. And based on inputs from the page or from them clicking on something, you can change the viewport however you want. You get very fine-grained control over exactly where the camera is positioned. You can create and move place marks, various kinds of geometries. You can create 3D models, move them around, create overlays, ground overlays, screen overlays, photo overlays. You can load KML files, and as I said before, integrate with other JavaScript APIs. So. Just to go over, these are the supported platforms right now for the browser plugin. So we support Windows and Mac. A lot of people saw our initial release, we only supported Windows, and so a lot of people never came back to notice that we now support the Mac environment as well. We support Firefox, IE, and Chrome, and Safari on the Mac. I don't think we've ever tested on Safari on Windows, but I think that's a pretty small user community. A lot of people ask me about mobile devices. At this point, we're not supporting any mobile devices, although that is obviously a direction that we'd like to see happen in the future. Okay, so I want to give a demonstration. Anybody who played with the Earth browser plugin in the early days has probably seen this one. This is a monster milk truck. And it pretty accurately demonstrates a lot of the capabilities that are inherent within the browser plugin. Unfortunately, it's not optimized for this resolution display. So you'll see down here, there's actually, you can do some input from the page. But one thing I want to show you is I can start driving this truck around. And for this I'm using the arrow keys on the keyboard. And every once in a while it will say something. And you'll see there, it's actually kind of fun. It's got 3D math code built in, or actually I should say it's not in the API, but it's in the open source library that we use to create this application. So you see how it goes over a hill and it actually kind of jumps there. And if you turn it, the milk truck actually leans. This is probably the most reused code of any of the Google Earth sample codes that we've given out, that people have used this in a variety of applications. So you see here, I'm going to jump to San Francisco here. And I just teleport to San Francisco and it drops in. And as I'm driving around, it's going to load in 3D buildings. Now, if I had been smart, I would have actually pre-cached these so it looked like they just loaded. But it's going to take a little bit of time to load them. Just as it would if you were using a standalone Google Earth client. And my browser decided to freeze there. Ah, there we go. Okay. All right, so that's a fun example, and it shows you that it shows a lot of the capabilities that you have. One is you can change the location by doing these sort of teleportation. You get 3D buildings, as you can see. These buildings just popped into existence. And you can drive right through these 3D buildings. So these buildings are actually a layer that we provide as part of the API. So all you have to do is, one line of code, you get 3D buildings all over the world. And as these buildings will become higher and higher resolution as you sort of sit nearby them. So if we were to stop here, you'll see the actual images, the textures on the buildings get more high resolution. That's the same 3D buildings layer that's available in Google Earth today. And actually, this one doesn't take advantage of it, but we also have a number of gray buildings, which are just plain untextured buildings. And those can be loaded separately as well. Okay, so let me go back to the presentation. I like, particularly with the Earth presentations, I like mixing in showing code and jumping back to demos because I think it's so visually powerful. Also, it keeps you awake at this late hour of the day. I don't know about you, I'm a little jet lagged. I'm about 15 hours behind my usual time. Okay, so how many of you have developed with KML before? Have you used KML to develop? Not very many. Okay, so KML, as I mentioned earlier, is the keyhole markup language. It's an XML declarative language for describing the display of geographic data in an Earth browser. It's actually an open standard. It was originally designed for Google Earth. Google released it to the Open Geospatial Consortium. So it's an XML language, which means anybody who's done any work with XML parsing, it's verbose, and you use, if you go through the DOM, you have to do all this complex DOM creation. And the Google Earth API actually mimics that process. So the Earth API is designed to be essentially a JavaScript rendition of KML. It also gives you a lot of additional capabilities, but at its core, you'll see if you know KML, you'll figure out easily how to build the most common pieces of the Google Earth API. So you see here at the top, this is creating a placemark. So a placemark is your fundamental unit of geometry. It's a point on the, your Earth browser. So you'll see here, we create a placemark, which is just, we're just creating a variable placemark, which is g.createPlacemark. And I could put a name in there, but I chose not to. And then I can set the name in the next line, placemark.setName. You are at Google. And then here I have, I create a point. Now a placemark in, I sort of misspoke earlier. A placemark in KML is not just a point, it's actually a container for a geometry. So a geometry can be a point, a line, a polygon, or a 3D model. Or it can actually be a multi-geometry too. It can contain a whole set of things. So in this case, we are creating a single point within the placemark. So you see here, a create point, which is g.createPoint. I assign it a lookat. So the lookat is the position relative to the point that the camera will take. And then I set get view, copy as look at. So this is all this does is basically takes whatever the current view is when I started this whole process. Whatever the current view is, it assigns that to that look at. And then the point, it sets a latitude and longitude. So this is basically creating a point in the middle of the screen with a look at of the current position. And then you set the place mark, you set that geometry to that point. So you're basically, you create the place mark, you create the point, and then you assign the point to the place mark. And then you have to append the place mark to the Google Earth plugin that you assign it to the DOM. So g.getFeatures append child place mark. So again, if you've done any DOM processing before, which you might have with, it's very common to do with JavaScript. This is essentially doing that for the KML DOM. So I wanted to show you next just some of the rich options that you get. By the way, are there any questions on anything I've talked about? Yes?
In KML, the 3D model is a collage format. But the
Yes.
first time loading it is very slow. Does Google Earth, okay, thank you. Does Google Earth transform them into a binary format so the later use is very fast?
Yes, so we have within Google Earth itself, it is stored as a binary as in the code, but it's also cached. So Google Earth creates a cache, and then it'll store the models in the cache as well, so it can reload them quickly. And the plugin will create a cache as well. And the caches can be shared between the Google Earth client and the plugin.
The same dictionary?
Sorry?
The same cache file shared with Google Earth and the plugin?
Yes. So if you create a Google Earth instance, if you load Google Earth and then you create a plugin instance in the browser, it will load the cache from the client. Much of the code is actually shared between Google Earth and the browser plugin. It's the same. The plugin is essentially a stripped down version of the client. You know, takes away much of the UI of Google Earth, and then adds in hooks for the API.
And the kernel is the same COM object or something?
It's an ActiveX control, and whatever the equivalent is on a Mac.
Okay.
Sorry, Windows guy.
And another question, do you have any plan to provide 3D models in China?
I don't know, actually. Do we not have any 3D models in China? Should have looked.
Too few, just a couple
Just a
of
few.
buildings.
Yeah. So actually, the 3D models are primarily created in the Google Earth. In the SketchUp 3D warehouse. So if you create 3D models and geolocate them and then upload them to the SketchUp's 3D warehouse, then they will become part of the Google Earth layer for 3D buildings.
Thank you.
After some moderation. We can't guarantee every model, of course. But. So yeah, we would love to have more models in China, and that's kind of up to everybody else. Any other questions? Okay, so let me show you, these are just some of the options that are available to you. You'll see down here, we have a list of these different options. One of them actually includes mouse navigation. You can turn this off very easily, just setting an option. And what that would do would be to prevent me from moving around using the mouse. Atmosphere, this is one a lot of people don't even realize that we have in the Earth client. You can actually turn it off there as well. But you'll see when you're at a distance, you can actually see the atmosphere effects as I turn those on and off. There's the scale legend, which when you get closer, will actually show up. That's this right here, this stuff right here. That shows you your distance in miles. We really should provide scale in kilometers for everybody else, but that's available in the client. I don't think that's available in the plugin. You can set an overview map. So here, you can also set its location. You can put a grid on there for latitude and longitude, and you can turn that off as well. You can add in the navigation controls. You can actually position these left or right. And you can also put in the status bar, which is this information down here. So those are just some of the options that are available. And I want to take a look at, show you the code here. Often with the things that just take that have a lot of code, I don't like putting it in the slides. Is that readable? Can everybody read that code? Can anybody not read the code there? Should I make it bigger? Okay, nobody's expressing opinion. I'm going to make it bigger. Okay, so where's the relevant stuff? All this stuff is just the creation of the objects, and here updating the options. That's the only additional thing. So let's do the update options. So this just sets the default options here, this function here. So you'll see the options is g.getOptions, and then you'll look through and it'll set the values of these options, the various options here, to the corresponding checkboxes. And then here it just checks to see if something is checked, it sets that. This here just looks at for, excuse me, if form.nav is checked, it sets the visibility of the navigation controls on or off. So it's pretty simple. You see one line of code for each option. Okay, I can see I'm taking a fair amount of time with this, but I want to keep going. So there are actually 3 different ways to load KML files. So a KML file, as I said, is an XML file that describes a presentation. And if you load the KML file into Google Earth, it will parse it and treat it just like, sorry, if you load it into the plugin, it'll treat it just like the KML file if it was loaded into the regular Google Earth. So the first way, and perhaps one of the easier ways to do it, is to create a network link. And so this basically mimics, there is a network link element in KML. So this basically just mimics the way KML loads a network link. So there you are, you create the KML, you can give it a description and a name, although that's not actually particularly relevant to you because you don't have a UI that sits in the left pane like you do in the Earth client. Set the fly to view to true. That's what that does is it just says, you know, if this is loaded, fly to the best view for this for the data that's loaded. It creates a link, sets the link's href, and then you add all of these things together and add it to the features. So that's a simple way. So I'm going to talk about the advantages and disadvantages of each way in a minute. This is the second way. This is fetch KML, and you'll see this is in terms of the lines of code, this is obviously very simple. You just one line of code, you load it, and you'll see there, you pass it the GE, the Google Earth object, you pass it the URL, and a function that loads when it's finished loading. And then the third way is if you want to parse a string that's just a string that represents the KML. And again, it's very simple. You just parse the KML string and then append the features to the ge.getFeatures. And this is, this would be what a very basic KML file would look like in string form. So when to use the different strategies. Network link, you can use a network link if you want to load the KML file dynamically. A network link allows you to do a number of different things. One of which is you can load, the easiest of which is you can load a KML file at an interval. So by default, it will load every 4 seconds. You can set the number of seconds for it to load that KML file. And the advantage to doing that is if the data changes, as KML files do periodically, it will fetch new data into your plugin. You can also set it to load when the view changes, so it can send some parameters back to your server that identify what the bounding box is that defines the viewport. And what that allows you to do is to just return a small amount of data that would be only the stuff that is viewable in that viewport. You can also set it to trigger on region. If you know anything about KML and regions, that's a good way to do it. So fetch KML allows you to fetch the KML file and load it directly into the KML DOM. So one of the major disadvantages of using a network link is that you don't actually know when the KML file is loaded, and you don't have any programmatic access to it. So you get this dynamic loading, but you don't get any programmatic access to the KML file itself. So if you use fetch KML, it's loaded directly into the DOM, parse KML as well, and you get, therefore, programmatic access to it. You can access the features that are loaded like you would any features that you create using the JavaScript API. The other nice thing about fetch KML is that when these things are loaded into the DOM actually lives not in JavaScript, but in the plugin, so it's higher performance. The plugin can offload much of the capabilities. Parse KML allows you to generate programmatically KML as a string. Are we playing with the lights? I think we're changing the lights a lot, aren't we? Sorry?
It will make the camera,
Okay. Okay. Sorry, I just was noticing the lights going on and up. So those are basically the different strategies you would want to use for loading KML files. Are there any questions on anything so far? No. Okay. I want to point out a couple of fun things. There's a gadget that you can load directly into your web page. This is something that we developed that allows you to basically, all you have to do is fill out this form here, and it will give you, when you click on get the code, it'll get HTML that will allow you to place that directly into your HTML. So you embed that gadget, and then you don't have to actually worry about programming the programming the browser plugin. You can just create this, point it at a KML file, embed that into your browser, and you're done. Okay, I want to do, this is my favorite demo so far. It's my favorite thing anybody's ever done in the Google Earth API. It's going to take a moment to load. This is I believe this uses some of the code that was originally developed for Monster Milk Truck. This allows you to pilot a ship in Google Earth. You can actually pilot one of many different types of ships, one of which includes that Zeppelin, or the airship. It's probably a word not many of you use. It's a Zeppelin. That's the thing floating way above the Earth. So you can pilot any one of those things. And I want to show you some of the interesting and innovative things that they did. So you see here there's a whole display down here. I'm going to select the cruise ship, because I really like the cruise ship. So there's this whole display down here that doesn't move. This right here. This is created using a screen overlay. If you're ever familiar with Google Earth, screen overlays are defined relative to their position. Sorry, their position is defined relative to the screen, not relative to the globe. So they sit, basically. They sit around. A lot of people use these for map legends, just a little thing up in the corner that says who made the map and what the different color markers mean. But he's done something incredibly innovative with this. So one of the things about screen overlays is they're not clickable. But watch this. If you'll notice there, I'm actually moving the speed dial here. And you'll see the ship begins to move. And here, I can you can hear the ship moving. I'm going to select the different viewports. So this is I think really done something really interesting here. So let me explain what he does. So as I said, screen overlays are not clickable. And the API doesn't expose any on-click functions for them. But you obviously notice that when I click over here, something happens. So he's faked it. He basically creates he detects where the click is, just as an on-click that on the globe on the plugin that detects where the click is, and then if it falls within the right pixel range, he does some change based on how that happens. So when I click here, it detects, oh, you're clicking on the control or the current location for the control. So I'm going to change the screen overlay. So he fakes these controls. I think that's pretty cool. I want to show you some other innovative things that he does. Look at the water. So here we're actually inside the ship. So you can see the model is actually hollow. You'll see here that he creates the wake. This is called a wake from a ship. It's what it leaves behind as it moves through. He's actually using ground overlays on top of the water, and he's changing the surface of the water. It actually gets really funny when you go over land, because of course, unfortunately, we don't at this point have land versus ocean detection. So in the API, so when he goes over land, it just keeps going, and a little wake will follow in its path. it's kind of funny, but I really like it. And you can see here, the ship is just keeping going. You can see it's going to head through one of the buildings pretty soon. Other fun things that he's doing is, of course, here he's got a map. So he's syncing the position of the map to the position of the Earth. So he's detecting where, and actually your viewpoint isn't changing. This is just changing based on the position of that ship. And of course he has ads. Want to monetize this in some way, right? Okay, so some of the advantages of the plugin over the standalone, the scriptable experience. So if you just use the standalone Google Earth client, oh, I only have 10 minutes left. Okay, standalone Google Earth client, you can load KML files, but you can't truly script it. And of course, in JavaScript, you can do that. You have control over which layers are displayed. One of the most common feature requests for KML developers. Obviously, it operates within your web page, and you can combine it with other JavaScript libraries and your own. Some of the disadvantages are that when it loads HTML, it scrubs it. So it takes out any JavaScript that's loaded in the KML file. So KML, in Google Earth 5.0, we allow you to load JavaScript. In the plugin, we do not. And that's for security reasons for the browser. And there's no programmatic control yet over time sliders and over the time slider and tours. These are things we do want to add in. I'm going to just go kind of quickly. I'm going to skip that demo. I want to show you Maps and Earth integration. So in Google Maps, if you add this line of code, you get an additional control that puts in the Earth button. And let me show you what that actually looks like. So here I'm going to load a Google Maps API application. This is Google Maps in the satellite view. And if I click on, so you see here, this is actually just a Maps. It looks very much like Earth, but it's not. If I click here, it'll load Earth, and we're now in a 3D view. And it looks very similar. Once the plugin actually loads for the first time, if I shift back to satellite, I just get a very smooth experience. And let me show you, this is my favorite part actually. If I tilt and then click on the satellite, it does a very nice transition back, very quick, and it's almost like they're the same experience. This is now the Maps view. Yes.
When you click Earth, there's a blink of the Google Earth
Default view. When you just click the Earth moment, you just click the Earth, and we noticed that there is a blink of the default Google Earth view. Is that inevitable? No, not this time, but the first time you load it.
Oh, yes, the first time you load it, yes.
So we cannot avoid it?
That's something that we're working on, but that is something that does happen the first time. And then it'll zoom back to the correct position.
Okay.
And I want to show one more thing, which is tours. Oops. My link here is not functioning correctly. So let me. I might be. Oh. Here we go. My internet access is actually running fairly slowly at the moment, so my apologies. Try reloading that. Okay, so this I may not be able to demonstrate touring because my access is rather slow. So let me just see if there was anything else in in here that I wanted to cover. So here's, there'll be links in my slides to the documentation. There's a rather nice set of utility libraries that we released. There's a developer forum, and of course the KML documentation, which is very useful for this. And now, I want to give time for questions. Any questions? Yes.
In HTML5, will that move into the old 3D or the 3D things? I mean, this KML.
Will we move Google Earth to HTML5? Is that what you mean?
Yeah. Become a special application of that.
So we haven't announced that we're going to do that. We will continue to look at how that will work. One of the disadvantages of HTML5, of course, is that it shows all your code, right? So if we implemented Google Earth in HTML5, we'd be showing you everything in Canvas, probably, right? So that would be something that we would consider to be probably a disadvantage. But on the other hand, it would prevent you from having to download a plugin to view a particular site. So we're looking at all of our options. What we have done is we've moved this out of labs. So we are committed to supporting the API for at least 3 more years. So if we decide to deprecate the API, we'll say, okay, from this point on, you have 3 more years. So that's one thing.
Maybe we change this question a bit. That given the internal implementation of this KML, can you repeat it within HTML5 with the equal efficiency now?
Not at this point. I've actually seen a couple of tests, but I think as browsers get more and more effective, you'll see more and more implementations like that. Yeah, I actually look forward to seeing other people developing KML readers that will be implemented in HTML5. Any other questions? Yes.
I have a question. I think the Google Earth is support the database. For example, I have some satellite maps in Oracle or Microsoft SQL server, and I want to load the maps from my local machine. I think whether Google Earth can load the lists directly or supported by the third software.
So the standalone Google Earth client can load, you would load them as ground overlays. So you would create image files that were projected in the right projection for a 3D viewport. So that would be WGS84. And then you would load them using a ground overlay.
Do you mean if I write some code in the server and provide a web service, and the Google Earth can visit the web service and load this data?
So there were two questions. One is that if you can load it off a local server, that's right?
Yeah.
One is if you can load it off your own arbitrary HTTP server. So Google Earth supports loading files via network links, so KML files, and it supports loading images as you can use it as tiles, or you can overlay them on top of the ground. So you can do that as long as that's what your application exports. One option is if your server supports a WMS server output, which is a standard, an OGC standard, then we can very easily support that in Google Earth.
Thank you.
Sure. Yes.
In standard of VRML, we have some definition of events, but we can't see this kind of definition in KML. Are you planning to add some in it?
So that's a really interesting question. Of course, the Google Earth API supports events. In KML is not, at this point, KML is not a scripting language. It's a presentation format. So it defines a way in which you can you define a presentation. So that's one part of your answer. The other part is that we don't actually add to KML. We do contribute to KML, but KML is an open standard under the auspices of the Open Geospatial Consortium. So you could join OGC and add and advocate for adding your events to KML. I'd suggest building an Earth browser that supports loading KML as it is, and then adding in your own extensions. So there's a whole extension mechanism for KML to do that.
Okay, in the future, what's the relationship between HTML5 or VARML or KML?
So they're all separate open standards. At this point, Google Earth uses WebKit to display the description balloon. So whatever WebKit, the version of WebKit that we're using, which in Earth on the Windows is Qt WebKit 4.5, whatever that supports, we will support from HTML5, we will support. And so I actually have a few interesting demos showing Canvas and, well, the dialogue tag. I'm not sure why they chose to it's not one of the major tags, but it's in there. I've seen on the Mac, I've actually seen the video tag functioning. So as WebKit progresses and supports more and more things, we'll support more.
Thank you.
Any other questions?
My question is, what's the further future of Google Earth? So will it be integrated with other Google technology like O3D or Google Map?
So that's a really good question. O3D is actually, I believe we're releasing that to the world, so it's no longer going to be a Google. It's not going to be a Google product, although we'll probably be supporting it and pushing it. But so this is a really good question, and unfortunately, this is one of the times you run up against. Well, at Google, we don't actually pre-announce anything usually. Every once in a while, we will, once we're really sure when it's going to happen. Yeah, at this point, we can't say much about the future. What I can say is that the Earth browser plugin and Maps will come together. So Google Maps will come together. I can't say whether or not we're going to try and implement it in O3D or what the future looks like for that. But it's a good question. We are looking at it. We're always, looking at, are we using the right technology and can we implement these in the future in a different way? But I think as with all of our Google APIs and developer products, you'll start to see things coming together. Any other questions? How are we doing on time?
We still have time.
Okay.
Last question, okay?
Yeah. So one last question.
That one, okay. Can you use the volume microphone? Okay, thank you.
My question is if whether Google Earth plugin be divided into different levels, like Google Maps, maybe buildings, cities, and the Earth. Is there will Google Earth plugin the KML or like the city GML standard?
I'm sorry, I didn't follow the question.
Because the city GML standard is divided different levels from
city GML.
Yeah.
Yes. So the city GML is an open geospatial standard, and CityGML is one of the standards within GML. I'm sorry. So what's your question?
My question is if Google Earth plugin will also be divided into different levels.
So I'm actually not that familiar with CityGML, so I don't know the details of it. We aren't at this point. We have a very smooth experience within Google Earth, and so we're not looking to create different levels within that. However, one thing you can do is use regions within KML, which support level of detail. I'm not sure if that's analogous or not, but if you want, maybe we can talk about that afterwards.
Thank you.
Sure. Okay. Well, thank you all very much, and I believe there's a few more activities, so enjoy the rest of the conference.